Okay, so we're going to give you another method of solving today, which is to solve by factoring. And factoring is a skill that you spend quite a bit of time with in Algebra 1. But we'll kind of refresh your memory here at the very beginning, and then do some examples where after we factor, we also solve by factoring. I do believe you spend a little bit of time in one of the last chapters in second semester covering quadratics, so it's possible that you have actually solved quadratics by factoring before. Just as a quick review for factoring is like the reverse of FOILing or distribution. So I'm just going to put two factors up here on the board real quick, x plus 2 times x plus 3. And you're probably pretty skilled with doing the distribution to figure out what this comes out to be as a standard form polynomial with like an x squared and an x term. So you would take x times x and get x squared. You'd do x times 3, which is 3x. 2 times x is 2x. And then 2 times 3 is positive 6. And then you do a little bit of cleanup with your like terms in the middle, so that you get x squared plus 5x plus 6. So this process is what you might call FOILing, or it's multiplication or distribution. And when we factor, you are given something that looks like x squared plus 5x, and you're asked to work backwards and figure out what it was before you did this multiplication or this distribution. What was it before you FOILed? And you don't have all the information that you need. You only get this version with the combined middle terms, so you don't really know what those two middle terms may have been. Okay. So it's possible in Algebra 1 that you learned some like special methods for factoring. And if you have a special method, after we review the factoring on the next slide, I'll ask you, like, do you remember how you factored in Algebra 1? Does anybody want to share that? Because let's say you all had class with Mr. Simpson. If Mr. Simpson taught you to factor in a certain way, then we could continue to factor that way. Otherwise, we'll just use my method, which is guess and check. Okay. So let's do some factor review. I've got 3 things to factor up here on the screen. The first one that I'll do is x squared minus 5x. Okay. And then we'll move on to some that have 3 terms. Those are called trinomials because they have 3 terms. But x squared minus 5x is a really good example for one of the basic factorings that's pretty easy, but sometimes it's like so easy we forget about it that we even have this option. So if you have something like x squared minus 5x and it only has 2 terms, all I do for 2-term polynomials is just check, like, do they share anything in common? So what does x squared and 5x have in common? An x. So that means I can factor an x out of both terms. So when you factor something out, it's like you're undistributing it. You're taking it out of both terms, and you're going to divide both terms by whatever you factored out and put that inside of a group of parentheses. So if I take x squared divided by x, what's left over is just x. And if I take negative 5x divided by x, what's left over is negative 5. So I factored the x out of both terms, and I'm left with x minus 5 as another factor. Now, you can check to make sure your factoring was correct just by redistributing. If you redistribute that x across both terms, does it go back to being the same thing you started with? Yes, so then you know you factored correctly. If you redistribute and it turns into something different, then you know you have a problem in your factoring and you want to go back and change it. Okay. But that I would describe as factoring out a greatest common factor. It's the most that they have in common is an x for both of them. We'll look at the middle one, which adds a term on the back. So now I have x squared minus 9x plus 20. Well, I look at all three terms. Do they share anything in common? Not anymore, right? Not all of them have an x. Not all of them share the same numerical factor. So what we want to do on this one is basically unfoil. What were the two binomials, two terms, that we multiplied together to get x squared minus 9x plus 20? To do this, I use what I know about foiling or distribution. And one thing I know about foiling or distribution is to get this x squared, I multiplied the very first terms in the group of parentheses. So what multiplies to make x squared? X times x. Okay, so I can put the x and the x there. Now the middle term is what I would describe kind of ambiguous. We don't know how we got the middle term because we had to add the two outside and inside terms. So instead of focusing right away on the middle term, I'll actually put my focus on the last term. Because to get this last number of 20, I multiplied the last numbers in the parentheses. So what can you multiply together to get 20? You can do -4, -5. There are other factors of 20, right? 1 and 20, 2 and 10. But you are not going to choose them because they won't combine to make that 9. So Sierra did a little thinking ahead and she said 4 and 5 will make 9. And they'll make -9 if they're both negative. Okay, so we'll put -4 and -5 in. And hopefully this is factored. I'm going to strongly encourage you to make sure that you do some checking. So if you're using this method, it's what I would call guess and check, and the check is the most important part. Okay? So it's easy for me to eyeball my first and my last terms. X times x is x squared. -5 times -5 is positive 20, because a negative times a negative will be positive. But you'll see me draw this a lot on the board. I'll check my outside term, -5x. I'll check my inside term, -4x. And I'll just double check that they make the middle term of -9x. They do, so I factored correctly. If they didn't, if I chose, let's say, -2 and -10, then I would add them up and I'd find out that was -12, and then I would go back and try a different pair of factors. So I encourage you to check your work. Now things get a little bit hairier in something like 2x squared minus x minus 3. So when the coefficient to the x squared is no longer 1, it's a little bit harder. Like Sierra knew right away, -4, -9. That becomes a little bit bigger challenge if you have something in front of the x squared term. So let's unfoil this. Let's make our two groups of parentheses. And again, start at the front of your polynomial there. What can multiply to make 2x squared? Jackson? 2x times x. Instead of just x times x, which would be 1x squared, we need one of them to have a factor of 2. So 2x and x. And then I still go back to the last number, which is -3. The problem with -3 is if you think about the factors of 3, 3 and 1, 3 and 1 can make either, if you add them, they'll be 4 or -4. If you subtract them, they'll be 2 or -2. And neither of those things is the middle term, which is -1x. But the key here is one of them is going to get multiplied by 2. And the other one is going to get multiplied by 1. So you have a factor of 3 and 1. You could think about, do I want it to be 1 and 3? Then my outside term will be 6x, and my inside term will be 1x. Will that give us -1x? No. So instead of 1 and 3, let's use 3 and 1. And so I'm going to drop the 3 and the 1 in. Will 3 and 1 multiply to make 3? In the back. Yes. Okay. And it will make a negative 3 as long as 1 will be positive and 1 will be negative. Okay. To figure out which one that is, I'm going to do those outside and inside terms. I'm going to get 2x and I'm going to get 3x. Which one of those should be negative? The 3x or the 2x? If you want your middle term to be negative 1x. Do you want the bigger one to be negative or the smaller one to be negative? The bigger one, so that, you know, same signs add and keep, different signs subtract, keep the sign of the bigger number. So we want to keep the sign of the bigger number. We want 3x to be negative. And so that kind of helps us decide this 3 must be a negative 3 and this must be a positive 1. So we'll put a minus 3 and a positive 1. So the key here is I call it guess and check, but it's so much more than guessing. You're putting some real thought into it, and you're thinking about what would happen if I refoiled this out. Like if I did the distribution, will it work out? 2x times x will be 2x squared. A negative 3 times positive 1 will be negative 3. And then in blue, my outside term will be positive 2x, my inside term will be negative 3x, and that will give me that negative 1x in the middle. Okay. So you really have to think about all those things that are going to be in play at the same time. Does anybody have questions about those 3 review problems? Okay, let's do some notes for what do you need to know to solve by factoring. So jot these things down. We'll talk about them, then we'll do some examples. So yesterday, when we talked about solving by reverse PEMDAS, my very first bullet point was use when you see only one x squared. Like you see x squared or a group of parentheses with an x inside being squared, but in the whole equation, you've got like that one term that's being squared. Then you can use reverse PEMDAS. If I introduce an x squared and an x term in an equation, those are not like terms. They will never combine together. They will never both disappear. Okay? There's nothing you can do to get that to happen. So your only option right now will be factoring. Eventually, we'll talk about quadratic formula. You'll factor the polynomial. You can use guess and check for trinomials. You can use the greatest common factor if you have only 2 terms. Check to see if they have anything in common. And then once you factor it, the only extra thing we have to do is set our factors equal to 0 and solve. So if we want our equation to equal 0, which is true if you go back to solving quadratics, we want to set our equation equal to 0 and solve for x. If we have 2 things that are multiplying to give us 0, then one or both of them has to be equal to 0. And that's why we set our factors equal to 0. Okay. So those are the steps to solve by factoring. Let's look at a couple of examples. Okay. So these would be what I would consider to be the easier versions. Okay. That guess and check isn't too terrible for these, because if you look at your x squared term, the leading coefficient is 1. Okay. So I have x squared plus 4x plus 3 equals 0. Since I have an x squared and an x term, I cannot solve by reverse PEMDAS. I'll never be able to get x all by itself. So I know to go straight to factoring. What will multiply to give me x squared? X and x. What will multiply to give me 3? 1 and 3. And then to get a positive 3 on my last term, I have to have the same signs in my parentheses. For the middle term to be positive, that means they both have to be positive. So it will be positive and positive. I will double check my outside and insides. This will be 3x. This will be 1x, and those will in fact make 4x. Okay, so everything checks out in terms of my FOIL. So I factored it, and now you have to solve it. Take each of these factors and set them equal to 0 separately. So we'll say x plus 1 equals 0 and x plus 3 equals 0. To solve for x, I'm going to subtract 1 from both sides. So x equals negative 1. To solve for x, subtract 3 from both sides. So x equals negative 3. Those are my two solutions. If I plug one of those back into the original equation for x, it will equal 0, like negative 1. Negative 1 squared is positive 1. Plus 4 times negative 1, that'd be 1 minus 4, or negative 3. Plus 3 is 0. It works. I could do that with negative 3 as well. Let's look at x squared minus 7x plus 12. It has an x squared and an x, so I can't solve by reverse PEMDAS. My only option is to factor. First terms must be x and x to get x squared. What factors of 12 will I use here? Negative 4 and negative 3. Negative 4 times negative 3 is positive 12. I agree. And negative 4 plus negative 3 is negative 7. I agree. Set your factors equal to 0. X minus 4 equals 0, so x equals 4. And x minus 3 equals 0, so x equals 3. I have two solutions. See if you can factor x squared minus 2x minus 24. Give it a go. Can you factor x squared minus 2x minus 24? And once you think you factored it, check it. I see most people putting in an x and an x, which I agree with. Excellent. And now we're kind of running through all those factors of negative 24, right? Did anybody find two factors that would work to give us 2 or negative 2, Riley? 6 and 4. They have a difference of 2. So when one's going to be positive and one's going to be negative, we'll get that middle term of 2. So we'll put in the 6 and the 4, and then think about one has to be positive and one has to be negative so that we get negative 24. To get negative 2, which one has to be negative? The bigger number, the 6. So it has to be x minus 6 and x plus 4. Okay. You can do your check so that you get positive 4x and negative 6x. And yes, indeed, I get negative 2x. But that check takes me approximately 3 seconds, and it's worth my time, because I'll get the right answer. And I set my factors equal to 0, so x minus 6 equals 0, and x plus 4 equals 0, and my two solutions are positive 6 and negative 4. Now, before we get to a couple of the more challenging examples, we have one other example on this slide, x squared plus 3x equals 0. What would you tell me to do in terms of factoring here? Because I have x squared and x, so I can't use reverse PEMDAS. How can I factor x squared plus 3x? If it has only 2 terms, what can I check for? Yeah, check for greatest common factor. So CR says, don't they both have x? Can't I take x out of both of them? Sure. X times x plus 3. Is that x squared plus 3x when you redistribute? It certainly is. Bless you. Set both of your factors equal to 0. So one of them is x equals 0. Don't have to do any solving. X plus 3 equals 0, so x equals negative 3. Done. If I plug those back in, they'll equal 0. 0 squared plus 3 times 0, 0. Negative 3 squared plus 3 times negative 3, that's 9 minus 9, 0. Okay, works out nicely. So don't be alarmed if you get to one that's missing the last term. Just factor out the common monomial. Okay, or greatest common factor. Okay. Now we need to look at some that involve a little bit more work to solve, because their solutions will look a little bit different than the solutions that we saw previously. We might end up with some fraction solutions. Remember, fractions are numbers too. We treat all numbers the same. We don't discriminate, so that's okay. So let's look at the first one here, 2x squared plus 7x plus 3. And we're going to set it equal to 0. Since it has x squared and x, I have to solve by factoring right now. I cannot use reverse PEMDAS. I can only do that when I have one x in the equation. So I'm going to have two groups of parentheses. What will multiply to give me that first term of 2x squared? 2x and x, thank you. What will multiply to give me the last term of positive 3? What are factors of 3? 3 and 1. And then you can do a little bit of planning here, like where do you want to put your 3 and where do you want to put your 1? If I put 3 first and 1 second, think about your outside and inside terms. 3 first will give me inside terms of 3x, and a 1 out in the back will give me a 2x. 3x and 2x, will that make 7x? No. So don't put 3 first and 1 second, put 1 and 3. Then think about your outside term here, you'll get 6x. Think about your inside term right there, you'll get 1x. Everything's positive, so our factors should be positive. Double check that everything is working. So like refoil in your head. You don't have to write it all out, but you should be really good at foiling. making sure everything works out, and then set your factors equal to 0. This factor of x plus 3 works out pretty slick. X equals -3. This factor, I have to do 2 steps. I have to subtract 1 so that I get 2x equals -1, and then I have to divide by 2. And -1 over 2 is my solution. That's okay. You can have fraction answers. Can you try factoring 3x squared minus 11x plus 6 equals 0? So that one's going to require a little bit more thinking and checking on your part. Could you please try to factor this polynomial? Give it a go, just like we did on the last one. Most people have 3x and x. First terms first. What can multiply together in the first position to give you 3x squared? Let's be a 3x and an x. Now you're wrestling with those last terms. You need factors of 6. So you have 2 sets of factors. You have 2 times 3 and you have 1 times 6. And you don't know which one is necessarily going to work because one of them gets multiplied by 3 and one of them doesn't. So this is where you can start some of that guess and check. I'm going to run through like how I guess and check. So I don't know what the right answer is. I'm going to try 1 and 6. My outside terms will be 18x. My inside term will be 1x. That will not get me 11x as a middle term. So that is not correct. I will erase those and I will switch this around. I will make it 6 and 1. And I will get on my outside terms 3x, on my inside terms 6x. It's close, 9x, but not 11x. So I'm going to erase those and assume that 6 and 1 are not my factors. So now I have 3 and 2. And I'm going to put a 3 and a 2, and I get 6x and 3x. I just check those same numbers, close but not quite. So I'm going to try switching them. I'm going to put in a 2 and a 3. And I get 9x and 2x. That's the one that works, right? So it may be the case, if you really are struggling, that you're just checking, one after another, until you find the one that works. Some people might be able to look at that and kind of tell which one is right, and might be able to kind of eliminate some of the other choices, like 1 and 6 were too far away, and they were going to get these really big numbers. But in order to make -11, they'll both be negatives, and then I'll set my factors equal to 0 and solve. So 3x minus 2 equals 0, and x minus 3 equals 0. I'll get x equals 3 over here. And on this one, I'll have to add 2 and divide by 3, so that'll be 2/3. If you need to do more of the steps for solving that 2-step, you can do that. If you can do it in your head and get the right answer, practice that mental math. So I will say factoring isn't always easy. It can sometimes be annoying, like on my last example when I went through all the possibilities and the last one I checked was right. But the more you factor, the better you'll get at factoring. So just kind of keep that in mind when you're practicing your homework and reviewing for your quiz. Okay.